Now before we begin the washer method, I want to make sure that y'all understand the this method first, and if y'all don't, that's completely fine, because there's a video on it that I have made in the description below, as well as a Calculus 2 playlist that I've been working on. Now the reason it's important to understand the this method for the washer method is because we use it twice. So let me put it in 2D form first with one big disk and one small one. And let's take the small disk away from the big disk, and that gives us a hole. So now we're left with a donut shape, or also known as a washer. So with this knowledge, our bigger one will be considered our f of x, and our smaller one will be considered our g of x. Hence, the bigger minus the smaller in the equation. Now let's put this into graphical terms with the equations y equals the square root of x and y equals x. So let's draw two separate graphs, and we'll also reflect it on the other side, as well as our y equals x graph. Now typically to determine which one is bigger and smaller, you can always put it all in one graph. The concept you want to understand here is the outer minus the inner. So when it's all put on one graph, you begin to realize our outer is the square root of x equation. So let's set that as our f of x. And our inner is going to be our x equation. So let's set that equal to g of x. And now that we've determined that, let's finally find our bounds. And to do that, we just set these two equations equal to each other, which then leaves us with x squared minus x, which can then be put into x times x minus 1, which equals 0. And now we know our bounds are x equals 0 and x equals 1. So that will be our a, and that will be our b. And bringing back the equation, let's write it down real quick. Pi times the integral of f of x squared minus the g of x squared times dx. And if there's a reminder that needs to be said, just remember that the dx is also known as the width, dx. Now let's plug in what we know. So I'll just take the integration of each using this method, which simplified becomes the integration of x minus x squared times dx. Now if we truly integrate this, we'll be left with pi times x squared over 2 minus x cubed over 3. And I apologize, I forgot to put our bounds, which is just 0 to 1, and then I'll put it up here as well, 0 to 1. So this will be bounded by 0 to 1. And now we are left with 1 over 2 minus 1 over 3 times pi. And let's find the least common denominator of these two, which we find out is over 6. And now we're left with 1 over 6 pi. And that is our answer. So in summary, when I explained it in 2D form, we're just taking the bigger disk and subtracting the smaller disk to find the area of the washer. And when I put it graphically, I chose the bounds y equals the square root of x and y equals x right here. And then I simply put it all on one graph and then integrated using the formula over here. And by finding my bounds, I just set our equations equal and finally plugged and chugged. And that's it.